Wow, that's pretty cool walk-on music. So good morning, everybody. I noticed in the app I got the title of Futurist. So I've never had that title before. So hopefully I'll do a good job at that. Thank you, Hugh, Don, for inviting me here, and I'm looking forward to this. This is not an audience I am used to speaking to, so hopefully some of the things I have to say will stimulate your thinking, and maybe as I have gotten older myself, my kids' thinking about what's ahead for all of us. I titled the talk Lessons for Long Life because really how I'd like you to think about it is, well, what is going to be long life in your careers, et cetera. And so what I'm going to do is really break this talk into a couple big parts. The first part, as we already have discussed, I want to talk a little bit about the Internet of Things. What does that really mean? I'm going to give you a little bit of a technology tutorial and expose you to both what is happening today as well as, I'll say, what I think is huge for the future. After that, I want to talk about what's the implication of all this technology. What's the implication on businesses that I like to say make things, make machines, make combine harvesters, make gene sequencers, and then what's the implication on people that use machines. And then I'm going to finish up by talking a little about what's the implication on us, on people. I'll talk a lot about machines, but I'll talk a little bit about people. I want you to think a little bit about what is the implication on people. And then finally, because I do teach at Stanford University, I like to give homework. So I'm going to give you a little homework to work on. I have had the privilege, as the introduction said, to kind of live in three worlds almost simultaneously. I did come to Silicon Valley 35 years ago to work for one of the original Kleiner Perkins startups called Tandem Computers, and have had a long association with startups in one form or another, including today, actually just this weekend, a company that I helped found with some of my Stanford kids. We just raised about $1.5 million in seed money, so I'm still very active in the startup space. I've had a long time in big companies at Oracle. These days, I actually serve on a couple corporate boards, including Blackbaud, as I know some of you may know who Blackbaud is, as well as just recently Teradata. And then finally, I've had the privilege to teach at Stanford for about 35 years. In the old days, real stuff, computer architecture. These days, I created a fluffy seminar class that I teach. So I don't have to do too much work. I do the first and last lecture, and in between I have guest lectures. But all my guest lectures are CEOs of public companies. And as my interests have moved into this Internet of Things area, we actually just recently had the vice chairman of General Electric, the CEO of Kaiser, et cetera, in the class. If you're at all interested in it, it's called cs309a.stanford.edu, and you can take a look at it. Anyway, with that, I'm going to say, hey, I wanted to talk about, I forgot, there's one thing I need to do. So I know, because I do a reasonable amount of this, that people in the audience are looking at me trying to figure out why I look like this, but I talk like this. So I grew up in the great state of North Carolina, so even though I've lived in California for a lot of years, if you're hearing any Southern in there, that's where it's coming from. So now you can pay attention, right? I have seen people just look at me and you're not paying attention, right? So I said I wanted to talk about lessons for long life, so I thought I'd start with lessons for long life for your personal life. This is actually taken from a temple in Kyoto, Japan. It's believed to be over 500 years old. It does indeed contain the 10 secrets to long life. So I see you guys are all writing it down. Okay, you don't speak Chinese yet, so here's the translation. You're supposed to eat more vegetables and less meat. You're supposed to have more sleep and less worry, more laughter and less anger, and then the one I've always been amused about, which is the more bathing, less clothing. I guess if you're a Buddhist monk, there's no television, so you got to do something to amuse yourself, right? So like I said, if I do nothing today other than teach you 10 lessons for long life in your personal life, I will consider it a success. I think let me start very much at the top, which is talk a little about the economy. I'll talk a little bit later about the global economy. I went back and did a little, some of you may have seen this kind of work. I went and looked and said, oh, who were the Dow companies in 1956, right, that formed the Dow Jones Industrial Average. So here's the list in 1956. Interesting, right? Okay, here's the list in 2015. There are only 3 companies who were in the Dow Jones in 1956 that still are there in the year 2015. Totally amazing, right? So I think everybody knows, although this is evidence of it, how much change is part of the world. I think what we're right in the middle of right now, or right in the early days, is, this is a World Economic Forum report that got released a couple years ago, most of the internet revolution, most of the software revolution up until now has really just changed, these couple industries. Financial services changed retail, changed media, right? But it's really only touched these industries. They say, and I fully agree with this, in the next 10 years, the Internet of Things will dramatically shift the rest of the economy, of the global economy, right? The global economy, 2/3 of the global GDP is not, right, financial services and media and retail. It's these bedrock industries, power, water, healthcare, transportation, construction, et cetera. So I know you came here to think, well, what is the Internet of Things? What does this mean, okay? So I'm gonna start out and tell you that really up until now, most of the technology we have built, right? I've been at Oracle, so ERP, CRM systems, frankly, any of the e-commerce stuff, any search applications, all of these are what I call Internet of People, IOP applications, right? Because fundamentally, they're designed to talk to us, right, humans. Okay, my Stanford kids, by the way, pay a lot of money to hear the next thing, so you're gonna get it at a much lower cost. So, things are not people. Things are not people. I know this is really hard to grasp, but things are not people. I'm gonna give you 5 reasons why things are not people, okay? First, there are gonna be way more things connected to the internet than there are people. If you listen to John Chambers at Cisco, he quotes a number 500 billion. Well, 500 billion is actually 100 times the global population. A couple of months ago, I was talking to the CIO at Extension Health. Some of you know who they are, big healthcare provider. He said, oh yeah, in our place, we already have more things connected than people. 1. 2, things can be where people are not. Things can be in your stomach, smart pills. Things can be a mile underground in a coal mine. Things can be out in the middle of the Australian outback, okay? So things can be where people aren't. 3, things have more to say, right? All we can do is type a little bit, click, move a mouse, etc. You may not know this, but a modern day wind turbine has 500 sensors sitting on it, right? So it has way more to say than we ever could. 4th, things can say it much more frequently. There's a machine in the coal mining industry called a longwall shearer. This is an incredible machine. It's basically a couple football fields long, 30 meters high. It basically digs through a coal seam. And as it's digging, it forms what they call an artificial roof. Well, one of the challenges they have is sometimes that roof collapses. If the roof collapses, they have to spend weeks digging out their $100 million machine, right? So they put sensors on top of this thing to try to predict roof collapse. Those sensors run at 10,000 cycles per second, 10,000 cycles per second. That is way faster than a human could ever type. And then the last one, and we can debate it, which is things can be programmed, people can't, okay? So if things are not people, then why would the technology that was built for the Internet of People work for the Internet of Things? And it is on that fundamental basis that I believe we're at the beginning of a next generation revolution in technology, all based on that fundamental belief, which is that things are not people, and we're gonna have to solve a whole new set of problems, and I'm gonna touch on some of those as we talk. So let's start by talking about the things themselves. I'm gonna talk about the things themselves, how those things are connected. We'll talk a little about connection technologies. What do you do to collect data from those things? What can you learn from them? And finally, what would you do differently? I'll make a fundamental point here. In the Internet of People, we had to build applications that did something so that we all would type or search or do something so that there would be data for us to go and learn on, analytics, et cetera. In the Internet of Things, I don't have to entice the machine to do anything, right? It's fine with reporting data all day and all night. So we actually could fundamentally think about learning from our machines before we figure out what to do with it, okay? So why has this all been happening? Well, at the root of it is sensor technology. Sensor technology has been driven down in price. Why? Well, every one of you is holding the answer to that question, right? It's this. Most people don't realize it, but your cell phone has 12 different sensors on it, accelerometers, barometers, et cetera. There's actually a cell phone in Japan right now which has a radiometer on it. You can guess why, right? Okay, right. If you think about it, I'm holding something which already talks to 12 sensors. It has a big computer on it with a lot of software, a lot of storage, and it talks to 3 different networks. And by the way, if I took the fancy case off of this and the fancy display, it probably cost about $50, right? Now, today, if you open up a tractor, a blood analyzer, right, a seed drill, any of these sorts of machines, you will see very primitive equipment inside them from a compute point of view. But I think it's not going to be too long until we see what I would like to say is a cell phone inside every machine, right? And by that I mean the type of compute horsepower that's sitting in this, right, which I've made the point is not very expensive, sitting inside every one of these machines. Now, in the introduction they didn't mention, I actually also teach a class. I started a class in cloud computing at Tsinghua University in Beijing. Every year when I go there, I meet some of my former students. And so last year I was meeting the guys at Xiaomi. Have you guys ever heard of Xiaomi? Okay, so Xiaomi is the world's largest manufacturer of cell phones. They make 80 million cell phones a year, 80 million cell phones a year. Okay, so amusingly enough, they are starting to saturate the Chinese market. So they're starting to think about how they expand into India, but they're also starting to think about new products. So I said, like what? He goes, and this is a very local product. So he wheels out this box, and it is an air purifier. Now, if you know anything about China's large cities, I mean, air quality just sucks, right? So an air purifier makes complete sense. Now, by the way, if you open up that air purifier, guess what you see inside? A cell phone. This is not too surprising because the vice president of engineering at Xiaomi was one of the original Google Android development engineers and was poached by them many years ago to come there. So it's running an Android version of an operating system inside there. It's not too surprising. So we may not be that far from a world where we've got way more compute horsepower sitting inside these machines than we ever did. So that's the thing itself. Okay, let's keep going. How is the thing going to be connected? Well, in the world of the Internet of People, we're very happy with 3G, 4G, right? Wi-Fi connectivity sounds good, right? Well, I'll give you a little story of there's a company in London called Sensium Vitals. Sensium Vitals builds a vital sign monitoring patch, okay? So when you go into the emergency room, they slap it on you. It does heart rate, respiration, et cetera. As a design criteria, they said, we do not want to put rechargeable battery packs on this thing because if we do, we have to wash the thing, we have to recharge it, so we don't want to do that. We want to just put disposable batteries. Well, as soon as they went to disposable batteries, they realized that they couldn't run Wi-Fi. There's not enough power. So they had to end up building what is referred to as a Zigbee mesh network. There are a lot of technologies starting to evolve at the low end of this conversation, meaning low power, low range, or long range, low power, low data rates. Companies are, efforts like LoRa, Sigfox, you may have started to hear these words, are starting to be out there to do this at the, we'll call it the low end of the range. At the high end of the range, let's talk about network technologies. You go, what is the most demanding networking application you can think of? And I'll give you the answer. It's probably either the World Cup, right? The broadcast of the World Cup, or the Victoria's Secret runway model show. right? Those are probably the two most demanding networking applications out there. You have a ton of content sitting in the cloud, getting pushed, right, into a lot of endpoints. Now remember back to my wind turbine story, what if I've got, and one of the largest manufacturers out there already has 15,000 wind turbines in the field. Each one of those wind turbines has 500 sensors on it, kicking out data once per second, and I want to push all this data up into the cloud. We're going to have much faster, what I refer to as reverse streaming networks than we ever had before. If you're interested in all this stuff, there's a lot of work going on in what is called millimeter wave, 60 gig technologies to do much higher performance networks than we've ever seen. Okay, so if I connect these things, then I can start to collect the data. Well, most people will think, yeah, and the book actually contains 12 different case studies. And you'll see a lot of examples of people using SQL databases, right, to go do this. But there's actually something more important going on right now. So I was talking to one of the big oil and gas companies earlier, and they were telling me about the newest oil drilling rig off the coast of Mexico, okay? So this oil drilling rig has 40,000 sensors on it, 40,000. I'm like, Jesus, what are you guys doing with all that data? And they go, well, most of it's digital exhaust. Digital exhaust is a great phrase, right? It's just going into the air. They're not doing anything with it. And the reason they're not doing anything with it is if you do the math, and it's not too hard, 40,000 sensors once per second, you quite rapidly realize you're going to own a lot of disk storage, and your EMC sales rep's going to be very happy. And if you're going to run an Oracle database, your Oracle database rep's going to be very happy because you're going to be buying a lot of this, right? So let's even assume that you go, yeah, okay, it's a $10 million purchase, and you walk into your boss's office and go, we should buy this. And she looks at you and said, well, what are you going to do with the data? And here's the big challenge, right? The current technologies, BI, analytic type, get a data scientist, they'll be able to visualize this, are not going to work. If you think about it, 15,000 wind turbines telling you the barometric pressure every second. I mean, what human can have any intuition over that kind of data? So I think what we're going to start to see is the advent of bringing the machine learning and AI technologies, which you are starting to see in the consumer internet, into this world, right? And there is a dramatic amount of progress being made in this. So let me just give you a little bit of, I saw AI as part of your conversation here. Let me tell you how fast things are happening. So there is a competition that's called the Imagenet Competition, okay? It is a competition between computers and humans on who can recognize images better. This first was run in 2011. The computers were 65% accurate in image recognition. Humans were 95%, okay? 2 years ago, computers hit 98% correct. They're actually better than the humans at image recognition. The game of Go. Most people had long forecasted that it would be 10 years before a computer could beat a human at Go. Well, that happened a year and a half ago, right? So why is this happening? Well, there's fundamentally three things, and I want you to think about this, that are coming together. One is the advent of a lot of technology which has been in the laboratory for probably 20 years and on, deep learning technologies, neural network technologies. These are now starting to come out in all sorts of different ways, particularly in open source, et cetera. So tons of software technology, one. Two, tons of compute horsepower for no money. I made the comment, I teach a class at Tsinghua, and so 7 years ago, I know the Amazon guys fairly well. They said, well, here's $3,000 worth of AWS time, right? Amazon Cloud Service time. So I showed up in class and said, you know, $3,000. Well, $3,000 buys you a computer in Northern California, Virginia, or Ireland for 3.5 years. And they all looked at me and went, oh, yeah, so what? I could have a computer underneath my desk in Beijing for 3.5 years. Why do I care? I said, yeah, I know. Or $3,000 buys you 10,000 computers for 30 minutes. 10,000 computers for 30 minutes. And the question that I wanted to plant in their head, and the answer is starting to emerge, which is what would you do with that kind of compute horsepower for no money? 2. 3, the advent of large data sets, right? Why does Facebook facial recognition work so scary well? Well, because they've got tons of faces in their databases, right? Why did the game of Go? Well, it's pretty easy to explain it. There were 1 million Go games that they trained the machine on. So these three things, software, huge amounts of data, and compute horsepower for no money, is dramatically, this is why when you see Alexa, Siri, all these sorts of things, why this is getting so good and so fast. We have the opportunity to take this same technology and apply it to our things, right, and learn from our things, and there's a whole new opportunity sitting out there. And if any of your kids are at all mathematically inclined, go tell them to learn about machine learning and AI, et cetera. There's a vast opportunity sitting out there. Okay. And finally, okay, what are you going to do with all this, right? Well, I could sit here and talk about middleware and applications, but I'm going to use this as an opportunity to shift gears. So I've talked a little bit about technology, some of the new stuff, but at the end of the day, like, who cares? I mean, it's fun for technologists to talk about it, but what's the implication of this? So I'm going to split my conversation into what's the implication of people who make machines, build machines, and what's the implication to people who use machines. So just as an example, Illumina builds gene sequencers. The Children's Hospital of Orange County uses gene sequencers, right? So let's start with enterprises that build machines. Why do they care? Well, there's fundamentally been two reasons. The first has been by you collecting data from these machines and learning from them, you can produce more reliable equipment. This is a combine harvester. Any of you have been in the wheat farming business or any of the grains, you know that you don't farm all year long or you don't harvest all year long. You only harvest in a time window. And by the way, you got to get the harvest in before the rains come, et cetera, et cetera. So your machine availability is very important to their world. So if I can use data to improve the reliability of my machines, I, as the machine manufacturer, am producing a higher quality product, right? Okay, the other is I can reduce the cost of servicing these machines. Some of you may be familiar with a company called United Rentals. United Rentals rents construction equipment. They do about $6 billion a year in construction equipment rentals. What you don't know is they spend $1 billion a year in maintenance, $1 billion a year in maintenance. And they are doing this the old-fashioned way, like we treat our cars, which is it's 6,000 miles, a little light comes on, we go change the oil. We all know that if I'm driving through the Mojave Desert at 120 degrees, I probably ought to change it before 6,000 miles. And if you get to live in California like me, I mean, you probably wait till 12,000 miles and it's just fine. So using just a small amount of data and information to be able to change how they're maintaining this stuff could, like I said, even a 10% change drops $100 million to the bottom line, okay? So these have been the classic reasons. But I think what's happening right now is even more important is what is the future of the machines themselves. So this, and I just got back from Vietnam, so I had to explain to people what a Tesla is. So this is the new Tesla Model 3. If you think about Tesla abstractly, it's a bunch of sensors, a bunch of actuators, a big computer in the middle with a lot of software, which is why you get new feature releases on Teslas every couple months. Now that's totally foreign to any of us who've bought cars before, that you would get new features in your car all the time, right? But that's easy to do once you see how much software is a part of what they're doing. They're not alone in this. The 2016 Porsche Panamera had 2 million lines of code in it. 2 million lines. That sounds like a lot, right? 2017 model has 100 million lines of code in it. 100 million lines of code. Medical devices. Actually, I think half the recalls of all the medical machines out there have been due to software-related problems. A modern-day MRI scanner actually has 10 million lines of code in it. So if you think about it, if the machines of the future are becoming more software-defined, then will it be true, and I believe it will be true, that the models, the business models that we've used in the world of software will transition into the world of machines? So I'm going to take you through that, which is what are these business models, give you a little bit of understanding of what has happened, I'll call it in my industry, and then how is this manifested itself in companies that make machines. We'll start with products and services. So this is a model which is I sell you the product, and then I sell you a service contract on that product, right? Some of you are familiar with this because you're Oracle customers. Oracle actually, in the year before it bought Sun, it was purely a software company. It did $15 billion in revenue, $15 billion in revenue. Now, 12 billion of that 15 was service contracts on the software that had been sold all those previous years. Only 3 billion was new product revenue, okay? Only 3 billion. And by the way, the margins on the service business are very high because at the end of the day, if you think of it, service is actually the delivery of information. And the margins on delivery of information can be astronomical, okay? Now, what you probably do not know and not have thought a lot about is the General Electric Corporation. Why has GE been talking about the industrial internet? If you watch Saturday Night Live, there's tons of ads, right? Industrial internet, hiring engineers, all this sort of thing. Why are they talking about this, right? I thought they built jet engines. Well, it doesn't take too long, and if you are interested, go download their 2016 annual report. Go to page 3, and you'll see the reason why, and I brought the graphic here, which is, and that's Oracle did a 12 billion of service revenue. Here's General Electric. General Electric in the year 2016 was a $110 billion a year company. They are a Fortune 10. Half of that revenue, $55 billion of that revenue, is service contracts on the MRI scanner, the jet engine, the wind turbine, et cetera, right? And because these service contracts are multi-year, they actually report a backlog of north of $250 billion. So remember, I made the point, service revenue is recurring. Service revenue can be very high margin business. So you can very easily, once you understand this, understand why they're so heavily investing in this space, right, to continue to drive, right, their service revenue business. Okay, so that's model one, sold you a product, sold you a service contract. Well, in the world of software, the next thing we did is said, hey, if I could connect to your server, I can provide you assisted services. I can say, hey, put this patch in and for security purposes, or change the disk configuration, right? And so we would provide these assisted services. I actually started this business at Oracle. We generate $300 million a year just doing that, providing assistance. So what's the analog in the world of machines? So you may never have heard of a company called New York Air Brake. New York Air Brake builds an IoT application. They connect to the locomotive. They collect data from the locomotive. They learn on it. And finally, they provide assistance to the train operator to speed up here and slow down there to save fuel cost. So Norfolk Southern uses them. They save about $6 million a year in fuel by using this system. Okay, so what's after? If I can tell you what to do, what's the last thing to go do? Just do it for you, right? So this year, Rio Tinto, a big mining operation in Australia, is going to run a totally automated train from the north of Australia down to Perth, bringing iron ore. There will not be a human on board. It will be totally automated, right? Now, in the world of software, we said, well, rather than make you figure out what patch to put in or how to manage the performance, why don't we do it for you? We called that software as a service. And so I think we're right at the beginning of now starting to see the idea of machines as a service. This is actually an industrial compressor company. They will sell you an air compressor. They'll sell you a service contract on the air compressor. They'll connect to the air compressor and provide assisted services, or they will provide you compressed air as a service. You don't need to buy any of the equipment. I don't do a lot of consumer examples, but there's a company in Brazil right now. You don't have to buy tires for your car anymore. You just drive up, they'll put new tires on it, and you drive off, and all they do is charge you per mile, right? So anybody who's been a student of what has happened, I'll call it in my industry, in the software and hardware world, knows how disruptive this business model can be. And I think the same thing is about to happen in the world of machines. There are leading edge guys that are starting to do this, and it's going to start leaving a lot of people behind as they make a significant business model change. So enough about people that build machines. Why do people that use machines care about this, right? Why would they care? Well, let me just give you 4 different reasons. The first is there are quite a few businesses out there where the consumables cost is the largest portion of their operating cost. And the one that we are all familiar with is the airline industry, right? Their operating margins are heavily dictated by how much jet fuel they use, right? So if they can operate their airline, their airplanes more precisely, right, they can lower consumables costs, improve operating margins. The one you may not be so familiar with is the world of gene sequencing, right? In gene sequencing, the so-called $1,000 gene sequence, $767 of cost of that gene sequence is actually chemicals, consumables. So taking the consumables cost down there would reduce the cost of doing gene sequencing, which has a lot of interesting implications. So lowering consumables cost, I can also, as an operation, produce a more reliable service. So utility companies, right? They use machines to generate electricity. So I'll tell you a story of Duke Energy. Duke, as some of you know, is one of the largest or the largest electricity producers in the United States. They actually right now have deployed 120 so-called phase measurement units, synchrophasers. These are machines that measure the phase angle in the electric grid. You go, why would you want to do that? Oh, by the way, these things measure it at 60 times per second, just to make that point again. So why would you want to do this? Well, it turns out if you could start measuring phase angle on the grid, you can start learning on it. And what can you learn? You can learn to predict blackouts. So if I can learn to predict blackouts, right, I can prevent them and therefore provide a more reliable service. Third reason, I can produce healthier products. So think about agriculture, right? So you're going to see some agriculture stuff later. So agriculture, right? Well, using less pesticides and less herbicides is a good thing, right? Because I've lowered consumables costs back to that. But if I'm in the business, right, and I'm using less pesticides and less herbicides, I'm actually creating a healthier product. Okay? And finally, I can produce safer systems, right? I started out my career at Tandem Computers. We built nonstop machines, highly reliable machines. We always had a joke about how do you build a reliable computer system. People say, well, how do you build one? I go, well, you get a man and a dog. Really? Yeah. Well, the man's to feed the dog, and the dog's to keep the man away from the computer, right? Because the number one reason why computer systems fail is actually human error, us, right? And it doesn't take too long, right, to look at a bunch of situations and realize that humans are at the source of failure of this, and we can vastly improve the safety of these systems by getting the humans out of the loop. Okay. What is the implication of this on the global economy? So I get the opportunity to teach at Stanford, as I said. So I use that to, as I like to say, warp young minds. So many of the kids, you'd be surprised to know this, are not sitting around going, God, I really want to go work at Facebook, or I really want to go build a dating app, or I really want to build another restaurant app. I want to do something meaningful. And I said, well, here, let me talk about meaningful. So if you think about the global economy is driven by developing economies, right? Developing economies are driven by population growth. So that's why the three central areas on the planet this is happening is Southeast Asia, Latin America, and Africa. Let me just take a second to talk about Africa because most people don't realize this. Nigeria is slated to be the third largest country in the world in the year 2040. It's going to be India, China, Nigeria. Right? 25% of the globe's population is going to be in Africa in the year 2040, right? So if you start thinking about these developing economies, right, well, you know, what are they going to need? Water, power, healthcare, right? The fundamental infrastructures, telecommunications. So I have a question, right? If you're going to go put in a telecommunications network in Rwanda, are you going to do it with first world technology, meaning let's go put up a bunch of telephone poles and string landlines around? You go, no. You'd skip ahead, right? You'd probably even skip out of 3G. You'd do 4G implementations, go cellular all the way. Think about electric power for a second. The way we have built electric power in the first world is we've said, oh, let's get a big coal-fired plant and hierarchically distribute, right, electricity through the grid, by the way, using AC technologies to do that. Well, in the modern era, why would I do that? Why wouldn't I put up wind where I could, solar where I could, small hydro where I could, run a distributed grid, right, and potentially even skip through AC and only generate DC. I have the opportunity in all these developing economies to skip ahead a generation, and that is a huge opportunity. Some of you know I actually just got off the plane from Vietnam. We just launched the book in Vietnamese last week. I got the opportunity to talk to over 2,000 students and over 200 business leaders and government officials. They actually are in the early lines of thinking of what is next for them, right? They really are, at this stage, a low-cost body shop, right? They actually, in the software business, you can get programmers there at half the price that you can from China, by the way. But they're starting to think, well, is it really going to be the case that we just want to continue being a low-cost provider of human labor? By the way, just so that you get up to speed, the country is almost 100 million people. Like 50% of the population is under the age of 30. So it's an extremely dynamic marketplace. So I spent a little time with them talking about what's the implication to Vietnam about this, and I'm just going to show you a couple things. So one is, we were actually meeting with the mayor of Hanoi, and he said at the end of it, he goes, oh, you know, we're actually about to deploy about 150 street sweeping machines out there, and we're planning on connecting them. I went, wow, that's pretty interesting. I said, well, what if you guys, right, connected to them, collected all the data from it, learned on it, and were able to do optimization or maintenance of the availability and performance of these street sweepers? I bet you could take that software and sell it back to the guys who are building these street sweepers. And oh boy, you should have seen, they was writing notes down left and right, you know. Okay, that's pretty mundane, street sweeping. They are also actually the world's largest exporter of shrimp at this point in time, okay? So if you think about aquaculture, right, shrimp farming, et cetera, one of the challenges they have is, well, you know, we need to move from just being commodity shrimp into branded shrimp. Well, what does it mean to brand something? Well, if you're going to brand something, ultimately you have to ensure quality and repetitious quality of a product to achieve brand. Well, how are you going to do that? Well, you're going to have to operate much more precisely. Being able to put sensors into the water, being able to change how the new shrimp equipment might look, right, is hugely an opportunity that they sit right in the front of. And I ended by talking a little to them about healthcare. They, like much of the developing world, if you think about healthcare, there is no way they're going to be able to do, quote, a first world healthcare system, meaning I'm going to build enough medical schools, enough hospitals to replicate, quote, the first world. But instead, I think they have the opportunity to leap ahead in multiple different dimensions. If you think about it, even our hospitals today are kind of antiquated by modern thinking, meaning we put all the equipment next to all the humans. Well, in the world of computers, we've gotten out of that. We put all the computers in one place and we build networks to attach humans to that. There's huge economic advantages in doing that. Why could you not do that in Vietnam? Centralize all the machines, right? Just as we've done with all the servers. And they actually sit with even a more unique opportunity, which is it is possible, right, given their political world, to actually sequence the DNA of all 100 million people. And once you can start to do that, right, the ability to predict cancer, cardiac disease, et cetera, just goes through the roof. So they have a lot of interesting opportunities in front of them from an economic point of view. So with that, I'm going to switch over, talk a little bit about us, people. What is all this going to mean to us, right? And then end by giving you, as I said, a little bit of homework. So you know, I know you're going to hear a little bit more about gamification later, but so I don't know how many people know what this is. World of Warcraft, right? WoW. So World of Warcraft, for those of you who don't know, is probably one of the largest multiplayer game systems out there. There are literally tens of millions of people that play this game. Now, why did I put this up here? Well, actually about 7 or 8 years ago, we got a bunch of Stanford kids together and we went to try to analyze this game. Why, right? Well, in this game, let me describe what happens, right? A group of people who do not all speak the same language come together for a short period of time, accomplish something, and then go away. And I go, God, in the world of work, we are always trying to figure out how to do that, right? How does it happen like repetitively in the world of Warcraft, and it's really difficult in our world? And so we actually went and tried to reverse engineer why is it that World of Warcraft works. I could do a whole long talk about this, but I'll just focus you on one thing to think about. In Warcraft, right away, when you go into Warcraft, you know by looking, right, at what level of person you're talking to, right? Yeah, he's a level 63 guy, okay. We know he has these skills, right? Now in our world, we don't know how to do that. The second part is, right, all the game is engineered so that no one person, you must have a healer and a warrior together because warriors can't heal and healers can't kill. So if you're going to go slay the dragon, you need both those characters. Now we know this is true in the world of work, but it is so fuzzy in our world. Increasingly, I believe in a global population, we used to have to be a bunch of generalists. If we're a little tribe of 500 people, we all have to learn how to do everything, grow food, make weapons, etc. But in a world of 3 billion, 4 billion people, 6 billion connected on the internet, work is going to move to the specialist out there. And so I heavily start getting the kids to think about, well, what is my specialization going to end up being? Because that's where the value is going to be accrued to. I saw the slide about, there's going to be work displacement. I get asked this question regularly, right, about, well, what's the implication of this technology to workers, right? They're going to be displaced. And I go, well, yes, I appreciate this problem, but I think it's even true at the, let's call it the high end of this. So I tell my Stanford kids, I go, the way I think you've got to think is it's not about going to school and then, oh, I get to work for 40 years. That's not the pattern. What this is going to have to look like is 10-year chunks is what I've been telling them. 10 years, 2 to learn, 8 to execute, and start all over again. We've used this phrase lifelong learning for a long time, but I think the reality is it is upon us as we speak. And I think the ways in which we as employers think and help our employees, the way we think as parents and help our kids, right? We've got to get people to start to realize that this is going to be the future. And if you're not on this cycle, it's not going to be easy, okay? And last, I think, as many of you who have been looking at education know, it's getting increasingly easy. The rote stuff of learning, by the way, machine learning, you can go take a class online on Coursera taught by Andrew Ng, the Stanford class, and it's free, okay? So the traditional, right, learning we'll call it the rote stuff, increasingly is going to be taken over by remote systems of one form or another. What we're going to be left with, and the question that I ask people is I go, can you teach creativity? Can you teach creativity? Because my observation's been, right, if you are interested, right, if you are sitting there thinking about what might be possible, right, that's where the germs of the next generation come from, is from thinking about that. That's what you're actually thinking about, not trying to, do multiplication or division or any of the rote stuff. So increasingly, can we teach? If we can teach creativity, that is going to sit at the core of any of the stuff we talk about as innovation. Okay. As I said, I teach school, so I like to give homework. So I'm going to give you a little homework for you to think about, okay? So I'll start with, in an agrarian age, right, we used to have to teach our kids how to farm. In an information age, we should teach our kids, right, about computers and software. And I think this is a little bit of a thing I've seen in Silicon Valley, which is you'll see these high school kids applying to all the name brand universities, and you'll ask them what are they going to major in, and they'll all go, well, I'm going to be pre-med, right? And so then I go, well, why wouldn't you be a computer science major? And they go, well, computer science is hard. I go, well, have you ever taken organic chemistry? Not easy, right? So, I think we have a responsibility to start to push people this way. I want to give you a little interesting stat. The #1 major for women at Stanford University is now computer science, by the way. And I think that we're going to have to take the step of moving this stuff into multiple disciplines. Part of the reason I started the class at Stanford, it's listed in computer science, but I aggressively go after everybody else on campus. So about a third of my kids are CSEEs, about a third are coming out of the MBA school, and about a third is everything else. So I've had third-year postdocs in the med school. Last year we had 8 kids from the law school, so we heavily try to push this out there into the community. Now, about 2 years ago, I was invited to talk to the staff at General Electric, Jeff Immelt's staff. And I thought, it's a dinner time talk, so I thought, well, what am I going to do? So I thought, well, maybe I'll do a talk called Why is Hardware Not Software? And I started out my talk and I said, well, guys, you know, I know it's hard to build jet engines and MRI scanners and all that sort of stuff, but at the end of the day, it's not software. And I took them through 2 or 3 fundamental reasons why they're very, very different things. Now, I was feeling a little bad after this, thinking, oh, I'm giving a bunch of old guys a hard time about not knowing about software. So it turns out last quarter I had a couple of my kids in class were mechanical engineers. And most of the guys who run these big industrial companies, that's what their background is, mechanical engineering. And so I was feeling a little bad. So I'm sitting down with these kids, you know, brand new Stanford kids. I go through their curriculum, and I come to discover there is no software in their curriculum, like 0, right? And in fact, if they're at all interested, they're told to go over and take the CS classes, which I happen to know what those are, and went, oh, you know, maybe, right? So I've been talking to people about, there's a whole idea in the world of mechanical engineering of mechatronics, meaning the blending of mechanical engineering and electronics. I think there's coming the time we've got to blend the worlds of mechanical engineering and software. And you know, maybe this is something universities take on, maybe not. Maybe this is going to have to happen in the rest of the world, right? Because I think this is high time that we're going to have to do this. This is going to even apply to things that are not, you know, what we like to think of as engineering curriculums. I mean, the world of insurance is going to change dramatically. If I can start to measure everything about cars, about buildings, about machines, right, how this will ultimately change the insurance industry is going to happen as well. I often ask people this question, which is, when is CIO a path to CEO? And most people look at me funny like, well, that never happens, right? It's the VP of sales that gets to be the CEO. Well, it can't be the CIO, right? And I go, well, let me just ask you one simple question. I said, who is the CIO at Facebook? Who's the CIO at Amazon? Who's the CIO at Google? And I go, yeah, I know you're thinking about the guy in the back office that's managing the SAP implementation. I said, but at the end of the day, Mark Zuckerberg is the CIO at Facebook. Jeff Bezos is the CIO at Amazon. Their business and software are totally intertwined. And I believe that's the future for every business out there. So we're going to have to get people on this line of conversation, getting people thinking this way. And I'll kind of end by saying it's never too late and tell you a story. I said I teach this class at Stanford. About 90 of my kids are local. About 10 are remote. 2 years ago, one of the remote kids sends me an email and says, oh, you know, I really like to meet the professor. I'm kind of old school. I said, okay. So we meet for breakfast. I'm sitting there. He arrives, and I look, and I go, God, you know, it doesn't look like a regular student. He sits down, and here's his story. He has an MD degree, an MPH, an MBA, and he has been chief of pediatric cardiology at Children's Hospital Orange County for 25 years. So I look at him and go, what are you doing here, right? He says, well, you know, I was watching Jeopardy, right? And I saw Watson beat the humans. And I decided it was time for artificial intelligence, big data, and cloud computing to meet the medical profession. I go, okay. And just like any regular person, he decides that in order to go do this, he needs a master's degree in bioinformatics from Stanford. Now, by the way, this is probably the top program in the country, right? So he gets admitted. Later on, we talked to the head of department. He goes, yeah, we admitted him because we were like, who is this guy? So he shows up. Now, they expect you know how to program when you arrive, right? That's just like opening stakes. He goes, I didn't have any knowledge of this, right? So he goes, I have a Python book over here and my homework assignment over here. and it takes him 3.5 years to complete a 2-year program. Why? Because he is still on call as chief of pediatric cardiology, right? Now, I tell this story because I go, it is never too late for any of us, right, to learn something new. So I encourage you, if you're at all interested in what I just said, Precision, the book has been out for about a year now. It talks a little bit more detail than what I said, tons of case studies to try to bring it to life. If you're at all interested in learning about this more, there's an online class that's just been released. You can go to this URL and go take it. It's tons of video, et cetera. So I'll end and by saying this, which is, unless we all go move to Mars, and I know there are people who are working on that project, but unless we all go move to Mars, we are going to have to operate a more precise planet. And I think at the end of the day, the technologies that I've just talked about, the business models I've just talked about, stand at the opportunity to go do that. It will be really the first time that technology can and will reshape the world. So with that, I appreciate your time and attention, and turn it back over to our MC.
There you go. Tim, it actually pains me to do this, coming from Duke Blue, but I guess I start to realize that if God wasn't a Tar Heel, why did he make the sky Carolina blue? Thank you very much, Tim, for sharing this.